This pendulum is beginning to move without a sideways push. It's going to be a problem getting the timing right on this, but by the end of this video, I'll share with you the one change that I made that actually got this from just moving to having a wide swing that kept going for hours. I started off designing on Tinkercad, and then once this was 3D printed out, I've got the pulley and a stepper motor and a rail. When you're pumping a swing, it's you that's putting in the energy. So that's what the stepper motor is going to be doing for us. It'll be moving the weight up and down, giving us the energy we need to keep the swing going. Yeah, that bearing's a bit tight, but at least it hasn't split. Okay, that's working quite nicely. So we'll need to use a stepper motor driver and an Arduino board to get this to work. You can't just start a stepper motor with full power, you need to accelerate up, but I want more acceleration than what I've got. Yeah, that sounds faster now. I also need to change the distance that it's travelling. So I'll go from 0 to 1400. Yeah, that's better. So I have to be honest, when I'm using heat shrink sleeving, I do tend to just use the edge of the soldering iron. Yeah, I know it's not ideal and it's messy. Mind you, I've seen that all the cool kids on YouTube do this. So maybe I should start doing that. Just need to connect the wires for the stepper motor now, in the right order. Actually, it's quite easy to find. There are just 2 coils on this stepper motor, so I just need to find the right 2 wires. There we go, there's the resistance, that's 1 pair. The Arduino program is now downloaded onto the board, and the board controls the motion driver, which controls the stepper motor. The USB cable gives 5 volts to the control board. Right, this is the pendulum setup. I've clamped the axle rod to 2 bars that support my slightly over-engineered camera tracker. So that's it, no hidden motors up here, it's just swinging on a bar. You might have noticed I've dropped the voltage from 30 volts to 20 volts. That's because I actually looked up the specification of the stepper motor, and this runs much better. And there we go. Purely vertical motion is inducing the side-to-side movement of the pendulum. So how is this related to a swing? Well, the ideal swinging position would be like this. Because the weight is lower, we get a larger swing on the way down, and then when we put energy in to raise the ball, there's a shorter swing on the second half. And then, on the way back, we can repeat the trick. But the length of swing time, the period on our pendulum, is only about 2.1 seconds, so we don't have enough time to lower and raise the ball 4 times in one swing. But we can have half the sequence, and that's what's programmed into the computer. Right, I've put a laser on so that we can see this easier. Let's start this off. That is cool. You can really see it starting to swing. Let's see that again in slow-mo. I'll keep this running for 10 seconds so that we can see the slow increase in amplitude. So it's all looking good. It looks like we're increasing the swing each time that the weights go up and down. But if you keep watching, you'll see there's a problem. As we go on in time, the amplitude doesn't continue consistently. See what I mean? The swing's getting shorter. Or, sorry, the amplitude. Yeah, we're almost back to where we started, but it doesn't stop. It recovers and we get back to increasing the amplitude again. Okay, I'm going to speed up the playback again and we'll see that the pattern repeats itself. Right, this is super fast playback. If you're enjoying this video, please hit that like and subscribe button. I really appreciate it. Thanks. So the problem is timing. The frequency of the weights going up and down is not the same as the frequency of the pendulum, so the system's out of sync with itself. So let's try and get a better idea of timing. I'll do what I did on the last video and use a video timecode generator but set it to milliseconds. That gives us a resolution of 33 milliseconds per frame of this video. Okay, first part of the swing to the right. The time to lift the weight, end of the swing right, then swing left, drop the weight, and complete the cycle by swinging left. And that's one complete cycle. So calculate that all out, and it gives us the lift and drop times and the time that we have to wait in milliseconds. And the wait times are different, which I assume is because we're effectively changing the length of the pendulum by changing the centre of gravity, which was kind of the point of this video, so that's nice. So these values are now programmed into the Arduino board so we can run again. Well, it's better, it looks slightly wider. Nah, it's going back again, isn't it? Yeah, there we go, almost stopped, and then starting again. So I tried this again with different settings. I was changing the wait time by increments of 2 milliseconds backwards and forwards. But to save you having to watch a 4-hour video, I'll just say I managed to get the swing wider, the amplitude, but the problem of it being out of phase, it increasing and decreasing the amplitude, was just the same. I'll jump the video a bit forward here. So it's still not right. And then I had an idea. I was trying to be too clever working out the different times between the top swing and the bottom swing. If I make both delay times the same, the pendulum will work it out for itself. Well, what I mean by that is that its speed and distance on each half of the swing will vary if the time is constant. So again, I'll save you the despair of trying all the different values, but finally, putting a value of 412 milliseconds began to look pretty good. So let's keep this running at normal speed. We'll take it up to the end of the black card and see where we go from there. Okay, spoiler alert, 60 seconds and we'll be there. so no sign yet of it decreasing in amplitude. So I'll speed up the playback of the film again and let's see what happens. I'll edit on these white arrows to show how it's increasing. So again, in the interests of anti-boredom, I'll take a screenshot every minute or so as it's increasing. And back to real time. Right, we need a bigger timepiece. And I'll switch the camera to time lapse. And I'll go and have my tea. So there we go. It never went back. It's quite happy to stay at that higher amplitude. And that would keep going for hours, as long as it had power to the stepper motor. So we have shown that a purely up and down movement can induce sideways movement. Having said that, it's only fair to point out, as I'm sure you've noticed, that the weights are slightly off-centre from the centre line of the pendulum, so that might help when it starts from rest, but I think that's all. So is this an efficient system? Well, it's using a lot of energy to raise the weights, and it's been running at about 10 watts, and there's no way that I could get that out from the output of a pendulum this size. I'm reasonably confident about that because I tried that on this video up here on the left, so you might want to check that one out. Anyway, thanks for watching, and I'll see you on the next one.